All right, so in this lesson, we're going to talk about solving trigonometric equations. And as you can see in the notes and on the screen, one of the most important parts of this section is to read the instructions. So for the first couple examples you see in the notes, it says find all real numbers that satisfy each equation. So what that implies is that by saying all real numbers, that we're going to need to give our answers in radians. And by saying find all of them, if you remember how the unit circle works, there are going to be infinitely many solutions. If we just keep going around the circle, we keep hitting that same terminal side, giving us different answers. So we'll go ahead and we'll take a look at the first example here, which is 2 sine x plus root 3 equals 0. So having understood the instructions, when solving a trig equation, the first thing you'll want to do is isolate the trig function. So sine of x equals negative root 3 over 2. Now, this is where we just kind of follow the same sequence of questioning that we've used in the past. We can see we want to find where sine is negative. So sine is negative in quadrants 3 and 4. So I'm going to go ahead and draw triangles in quadrants 3 and 4. The ratio that I'm given here, negative root 3 over 2, suggests that this would be a negative root 3. That would be a 2, a negative root 3, and a 2, since we're dealing with the sine trig function. You can fill in the other side if you need to. And that picture then suggests our reference angles are pi over 3. So the answers that we need to give would be this angle right here and this bigger angle right here. So for the first one, we would have x equals, looks like 4 pi over 3. And then for the second one, x would equal 5 pi over 3. So individually, those are the angles that I have drawn on the screen. But as I mentioned before, if I wanted another coterminal angle with 4 pi over 3, I could simply just add another 2 pi to it. So when we tack on this 2k pi on the end, where k is an integer, it just takes us around the circle again in either direction, leaving us off at the same place. So I'll tack on a 2k pi to that one, and so those would be the answers for the first example, specifically all real numbers that satisfy the original equation. All right, so for this one, same instructions. So we'll go ahead and isolate the trig function. So tangent of x equals 1. Again, tangent is positive. Tangent is positive in quadrants 1 and 3. So when we draw this triangle and we label accordingly, this would be a 1, a square root of 2, a negative 1, square root of 2, suggesting our reference angles here are pi over 4. So then the answers we would give would be this angle and then this larger angle right here. So x would equal pi over 4, once again plus 2k pi because of the instructions. And then the angle in quadrant 3 would be x equals 5 pi over 4 plus 2k pi. Now, that's not the final answer that we'd want to give. Tangent's a very unique trig function. When we go through our sequence of questioning up here where we say tangent is positive in this case, or even tangent is negative in some cases, you'll find that when you draw the triangles, you'll always be in opposite quadrants. This implies that you can actually take both of these answers essentially and combine them into one. So if I take pi over 4, and instead of adding 2k pi, just add k pi, this actually summarizes both of the other solutions you saw written there in black. So for tangent and cotangent, you can get away with writing it like this, which is the preferred way. All right, so on to example 3. Notice in example 3, the instructions do change. Now it says instead of all reals, we want all alpha between negative 360 degrees and positive 360 degrees. So this implies two different things. First of all, we want to give our answers in degrees instead of radians. And then second of all, you'll have a finite number of solutions here because the instructions have limited you to one revolution in the positive direction and one revolution in the negative direction on our unit circle. So other than that, we'll approach it the same way where we try to isolate one of our trig functions. So what I'll go ahead and do is I'll move this guy over here and I'll move this guy over here. So that's going to give us the square root of 12 minus the square root of 3 equals 2 cosine alpha. We know the square root of 12 is 2 root 3. And so 2 root 3 minus root 3 gives us just the square root of 3. And so my last step now would be to divide by 2. And I would see that cosine of alpha equals the square root of 3 over 2. So a little bit of algebra there. We're able to get that trig function isolated again, though. So we'll follow the same pattern. Cosine is positive. So cosine is positive in quadrants 1 and 4. So there's one of our triangles. There's the other one. Marking it, we've got a square root of 3, a 2, and then we'd have a -1 and a 2 on the bottom one. And so it looks like that suggests our reference angle is pi over 6 on both of these. And I've actually, and pi over 6 is fine. Hopefully, like you, your brain has been trained to think radians. I am going to backtrack a little bit, though. Remember, we do want degrees. So just to be 100% clear in what I'm writing here, let me go ahead and change that. Instead of pi over 6, I'm going to write 30 degrees as our reference angle. So again, hopefully your mind is starting to be trained that same way as well, where it is kind of difficult to remember degrees, but we do need to follow the instructions. So 30 degrees. So it looks like, again, the angles are going to be a finite number of solutions. So we'll need to give this one, and it looks like this one. So from those two, you can see that alpha would equal 30 degrees. It would also equal 330 degrees. And then actually going in the other direction now, we could give this angle, which is -30 degrees, and this other angle, which would be -330. So it looks like we have plus or minus 30 degrees and plus or minus 330 degrees. That would satisfy the original, again, in degrees. Notice all my numbers are now back in degrees, between -360 and +360.